Alright, in this problem we're given 4 points, which are the vertices of a rectangle, and we're told that a point at random is selected from the interior of the rectangle. And the question is, what is the probability that the x-coordinate of the point is negative? Okay, so the x is negative and the y is positive. Alright, well, let's draw a picture. Okay, so let's draw what these 4 points look like. So I'm going to scroll down and give myself some room, and I'm going to draw a coordinate system. Let's see if I can draw some straight lines here. Let's start with the x axis here. So I'll draw the x-axis there, and how about if we draw y-axis? I don't know, about here. Let's see if I can draw it reasonably straight. Okay, well, that's not real straight, but you get the idea, I think. All right, so let's mark out. Okay, the first point is -3, 6. So, and remember that the x-coordinate always comes first. So this is the x-coordinate of this point A, and this is the y-coordinate. Okay, so it's alphabetical, so it's not too hard to remember. Okay, so we want to go 3 to the left on the x-axis, and we want to go up 6. So let's go 1, 2, 3, 4, 5, 6. And so our point is right about here. Okay? So I'm going to draw a little dashed line across here and down to there. Okay, so this is -3, 6. All right. Next point is 8, 6. So 1, 2, 3, 4, 5, 6, 7, 8. So that point is right about here. So this is point B, and it's 8, 6. All right. And I'll draw a little line because this is going to end up being a rectangle. All right. Point C is 8, -4. All right, so 8 to the right on the x-axis. And I'll label this y. And then we go down 4. 1, 2, 3, 4. So our point is down here. 8, -4. Alright. Alright, so let's see, one more point. -3, -4. Alright, I bet you it's right here. That's easy. -3, comma, -4. Okay. So we have this rectangle, and we want to know the probability that if we choose some point at random in this rectangle, so say we're throwing a dart at it, and this is our dartboard, then what's the chance that the x-coordinate is negative? Okay, x-coordinate negative, that's over here, right? And the y-coordinate is positive. Okay, so we're essentially talking about this area right here. So what's the chance that the point we pick is in this portion of the whole rectangle? Alright, so we're asked to calculate probability. Okay, so like we've said before, the probability is equal to the denominator is the total number of outcomes, and the numerator is the desired outcomes, so number of desired outcomes. Oops, running out of room. Okay, so our desired outcome is this area here where the x-coordinate is negative and the y-coordinate is positive. Okay, but if you think about it, there's really an infinite number of points in that area. There's an infinite number of points in this whole rectangle. So we have to take a little bit different approach than we have in the past, where we've had easily countable things. Okay, here we have an area instead. So basically, we just need to figure out what portion of the whole rectangle is this portion over here in quadrant 2. Okay, and if you've seen quadrants numbered like this, but oftentimes quadrants are referred to as 1, 2, 3, and 4. So the negative x, positive y quadrant is this one right here. So we're looking for the portion of the rectangle that is within the second quadrant. Okay, so we can just compare areas, and the areas are easy to compute. So essentially we've got 8 over here, 3 over here, so this is an 11. Dimension across here is 11. Dimension here is from 6 to negative 4, so the length and width are 10 and 11. So the area of the whole rectangle is equal to 10 times 11. Okay, so that's our denominator. Whoops. Reset. Because that corresponds to the total number of outcomes. Okay, so it's the total area of the rectangle is sort of equivalent to the total possible outcomes. Okay, if we know that we're going to pick a point within this rectangle, then there's an area of 110. Okay, so then we can just compare it to the area of this. So we have it's a 3 by 6, right? So we're talking about, what, 18. All right, so there's our fraction. That's our probability, but we can reduce that. This is the same as 9 over 55. So in lowest terms, this is the probability that if we pick a point at random, that it will be a point in this second quadrant. Okay, so there you go.